Hello CP Finitians and welcome to 7.2 Complementary Events. That is a very nice hat you have on there, sir. Not that type of compliment actually, but hey, whatever floats your boat. Complementary events, on the other hand, are events that are opposites of one another. Okay? It is just like last chapter when we looked at things like this is not A and not B, and we are actually going to see that same terminology used throughout here. So, for probability, the probability that Mr. Dowie says it will snow tomorrow is 68%. What is its complement? Well, the complement would be not snowing, and that must be the opposite. So complement is always going from 1. So 1 minus 0.68, that is 68%, okay? That is 0.32. The complement of snowing is not snowing, and it's specifically a 32% chance, okay? Not too crazy, hopefully. Probability of rolling a 5 on a die that's 6-sided is, okay, 1 out of 6, sorry. That's the probability of rolling a 5. Its complement, well, that would be not rolling a 5. Okay, so if you think that means getting a 1, a 2, a 3, a 4, a 6, that means it's 5 out of 6. Okay, so that is the probability for that specific case. What we designate for complement, when I want you to find the complement, is you'll either see it just as before with the little fancy A, or it'll be P of A, boop, with the little fancy sign there. And basically that just means you're taking 1 minus the probability of A, and in this specific case it is 0.52, so probability of A fancy, or not A, is 1 minus 0.52. Simply put, it is 0.48. Okay? Basic stuff there. But wait, there's always more, because we get into everyone's favorite Venn diagrams. So, looking at these here, pretty much the same idea, only the new piece of information is that we always know the universe is equal to, for probability, something should be going off in your head, universe is always going to be 1. Okay, all of the pieces, so let's say this is part I, we'll say this is part 2, part 3, and part 4. We're not going to be looking at adding to anything other than 1. That's what they're always going to add up to be. Now again, the different parts, event A, event B, of course, where they overlap, where maybe both events happen, is the middle. So this is, if you recall, A and B intersect. Okay? And simply put, this is A only. Okay, if you recall that. So in red here is only A. In blue here is only blue. Only blue. And outside here is actually the probability that neither happens, okay? So this is the probability of A union B not, okay? So that is what's outside here. Again, the more we work through, the better you'll become, okay? So simply put, again, probability of A is 0.2. Well, that is all of A is 0.2, okay? That means even in the middle there. Probability of B is 0.6. Probability of A and B is 0.1, so now the ball starts rolling. 0.1. That means if the whole circle is 0.2, this must also be 0.1, and then this must be 0.5. If that is like, what? Where did he get that from? Again, 0.6 minus 0.1 means only B must be that. Now, we have to remember what might be outside. Okay, well, 0.5 and 0.1, and 0.1 is 0.7, that means there is a 0.3% chance of missing it all. I kind of like to think of this as a dartboard, okay? If you're throwing darts and you have the opportunity to either hit the red side or the blue side, your probability of throwing the dart, let's draw a little dart here. That is a terrible dart, Dvorsky. We'll feather it out here. Okay, the probability of throwing a dart and it landing in the red zone is 0.1, so just 0.1 in the red only. Probability of it hitting the blue only is 0.5. Probability of hitting them both is 0.1, and the probability of missing the board, so it's almost like missing entirely, is 0.3. Okay, so there is a little dartboard example. Following the table, you can basically answer these problems. Now, be careful. So this is like saying probability of not hitting B. Okay? So I'm going to highlight everything that is not B in, we'll do yellow. Okay? So just to specify, everything that is not B is going to be in yellow. Okay, well, you'd say, hey, this is not B, certainly. Okay, so a 0.1. But I could also miss the entire board and hit everything outside, which would be another 0.3. Okay, so the probability of completely missing B is 0.4. All right, that's the only thing. Just don't forget about the outside. Similarly, if I don't want to hit A, so don't hit A, okay, that means I can hit any piece of B or miss the board entirely, and I can do so with a 0.8% chance. Probability of not hitting the union. This means not hitting A or B. That's everything in the circles, okay? Or in the middle. So that means everything on the outside. And that means the 0.3. Okay, again, it's right there. And not hitting the intersection, that would be A only, B only, or the no hit zone. Okay, or you miss the board, so that would be 0.1 plus 0.5 plus 0.3, and that would be 0.9. Okay, definitely, and by the way, we are going to look at Venns of 4. I'm just kidding. No, we're not. Okay, we are actually only going to consider Venns of 2, so make sure that you memorize the different pieces. This is missing the board, A or B not, A only, B only, intersection. Just kidding about the Venns of 5, okay? So what I'd like you to do, of course, is to post an example of an event and give a probability. So the probability of A, and provide its complement. And just so you're not confused, I also want you to give, so this is 1, 2, well, really 1, 2, and 3. I want you to give another student a complement, such as nice hair, nice shoes, something like that. So complementary events with an E, complement is with an I. Have a nice day, guys.